Hello. Thank you for joining us today on this DevClub. My name is Aleksandrs. I hope you will enjoy this presentation and find something useful in it. And I hope that it will not be very boring for you. So the topic of the presentation is enhancing CI and CD pipelines. The road from Docker Swarm to the Amazon EKS. A little bit about myself. I'm working around 5 years at INTEXSYS. Currently, I'm a software architect and leading a team that is responsible for supporting and managing our e-commerce solutions. And despite we are not a DevOps team, we often do operations-related tasks. As INTEXSYS, we provide e-commerce solutions and automation systems. And one of our biggest clients is Aleksandrs, which is a very huge US holding with more than $500 million of turnover yearly. You also can know some of our local clients like TED, Beans, or Begonia. And today I will tell you about our journey of adopting the Kubernetes in our infrastructure. That started from the project of enhancing the CI/CD. I will tell you about what our CI/CD looked like, why we decided to use the Kubernetes, a little bit about evolution of our cluster and the problems we have faced during the development of it, and a little bit about how we are using Rust in this context. A brief introduction of our platform. For more than 10 years, almost 100 of developers are actively working on supporting and maintaining it. It's called eCore. So you might assume how big it is and how many features it has. It's mostly a monolithic system based on the Symfony framework and written in the PHP. And it has multi-store support feature. A few years ago, we decided to split this monolith into microservices, and now we have a bunch of them and different subsystems. But further, I will be talking about everything in the context of this monolith. Let me briefly remind you what the CI/CD is. It's basically methods and practices for shipping your features to the production. CI stands for continuous integration, and CD stands for either continuous delivery, which is basically a method, a semi-automatic method for shipping features to production, where it can be decided when to deploy, and continuous deployment, the process that is fully automatic and everything is done without human intervention. A little bit about state of our CI/CD pipelines. We are utilizing the Atlassian stack, which includes Bitbucket, that is a version control system, and a Bamboo, a CI/CD tool. So when the code is pushed to the Bitbucket, it is triggering the build in the Bamboo, which then calls a sequence of actions on the build server, and with the help of scripts and deployer, which is a PHP tool that provides features for provisioning servers. It has some pre-made recipes, or we can write our own. And as a result of this stage, we have an application code, which then is later reused during our testing pipelines, which includes unit testing via the PHP unit and acceptance testing with the Behat, which is a behavior-driven development framework. Or you might know the Cucumber. It's basically the same. And BDD provides a way to write tests in a human-readable form that are easily understandable by non-technical people. And if everything is good and the build is green, then we are just deploying the application to production. And this approach had flaws. The CI/CD was taking many hours. We had large queues, and it was unstable. We had a lot of flaky tests, and each build had a lot of failed ones. So developers was forced to review all the results of testing and decide which tests failed for a reason and which failures were just false positive results. And there were no scalability, so execution parallelism was limited. As a solution to improve the situation, we decided to use Docker. I assume you all know what it is. And we decided to put everything inside the Docker that we could and use some kind of container orchestrator to manage our Docker stacks of containers. And as an orchestrator, we have used the Docker Swarm in the cluster mode, which provided an ability to combine physical servers into one big cluster. And why Docker Swarm? Because it was really easy to set up. It was native to the Docker, which we had experience with already. And to not overcomplicate the things, we agreed to try it out as an experiment. And as an improvement, now the Bamboo was calling with the help of Docker Swarm a process that was creating a build container that was producing Docker images that was later utilized during the test pipeline for the unit tests and for the beheads. For beheads, we created consumers, and that was consisting of different containers like headless browser, Phantom.js, database, Apache, PHP, and other containers. And those containers were fetching the queues, fetching the tests from the RabbitMQ queue, running them, and that's it. As a result, we managed to increase the delivery speed from the many hours to around 20 minutes. We achieved a fault tolerance for our pipelines, added a self-healing mechanism, and achieved the stability. And also, everything became scalable. It means that plugging in new servers became a very easy task. And it was a very brief overview of the pipelines. We already did presentation on one of the previous DevClubs. It was around 4 years ago, I guess, where everything was described in a great detail. So you can look at it if you want to. But after some time, we saw that there were issues with the Docker Swarm. The cluster, randomly, for no apparent reason, was just breaking apart. And we had to recreate it once in a while. There were no atomic scheduling feature. It means that we couldn't start either all of the containers from the stack or none of them. So there could be situations where we have partially initialized stack that is not doing anything. And Docker Swarm didn't have some advanced features for managing the stacks that we wanted to have. And at that time, it was not very popular and maintainable solution. So we searched through the alternatives. You can see some of them. And we were already looking at the Kubernetes at that time, so we decided to try it out also as an experiment. And since I will be talking about some of the stuff from the Kubernetes architecture, I would like to briefly remind you what there is. So a basic cluster consisting from the master node that hosts a controller, control plane components, and there could be many worker nodes. If the cluster has multiple masters, it's highly available. And the control plane contains such components as API server, that is a front-end of the container orchestration layer, a scheduler that decides where to put new workload, controller manager that tries to keep the desired state of the cluster and making adjustments in it if needed, the etcd, key value storage for persisting the cluster data. And there are also some components like container runtime, or Docker in our case, like kubelet agent that makes sure the workloads are created, and so on. So we created our first cluster using the bare metal machines that we had. It was not very large, from the 11 nodes and one master, and the version of Kubernetes was 1.8. It's around year 2018, I guess. And we created it using the kubeadmin, a utility for managing and provisioning clusters. And some of the features that we have used for our CI/CD pipelines were the priority classes that provided a way to set the priority of a workload, which was used by the scheduler in order to decide which workload can be preempted or evicted in case of resource starvation. And we created a bunch of those classes and utilized them in our jobs, so it became possible to, for example, start for a master build to steal the resources from the CI pipelines of feature branches if there are not enough resources. We also configured resource management for most of our workloads in terms of CPU and memory. And there are requests and limits type that Kubernetes provides. And the limits is basically a threshold, which means that if it's exceeded, in case of CPU, the workload is being throttled. In case of RAM, it is being killed. Kubernetes provides an auto-scaling feature out of the box where you can set the scaling for your workloads based on the specific demands, where demands can be set using some metrics like CPU utilization. But unfortunately for our pipelines, it was not working, since we wanted to scale our consumers based on the number of the tests in the queue, and the custom metrics was not supported at the time. So we created a custom autoscaler that was just polling the data from the RabbitMQ queue, and if the amount of consumers were greater than the number of tests left, then we were just scaling them down. And it is working till now. Imagine this situation. For example, we have a test consumer that is in the middle of running test, and then we are receiving a termination signal for some reason, maybe because of scaling or eviction. And the containers are started to being terminated, and it will happen in random order. And if the MySQL container is terminated first, and the PHP container is still running the test, then the PHP container will tell that the connection to the database was lost, and the test will be failed. Luckily, Kubernetes provides a feature that provides a way to track the life cycle of pods, container from the pods. And there are a few types of them. Post-start hook, that is basically being called after the container start, and pre-stop hook, that is being called after the termination signal is received. So we utilized this hook and created a logic that was waiting till the test completion before terminating all of the containers. For monitoring the CI, we deployed a simple stack from the Fluentd that was gathering logs from the consumers, and it was saving them into Elasticsearch, and we was debugging them in the Kibana. We also deployed a Kubernetes dashboard, a very convenient UI for managing the Kubernetes cluster at the time. And also, we deployed a stack for monitoring the system and state of our cluster from the hipster that was harvesting the metrics from the server nodes and storing them in the InfluxDB. And via Grafana, we also configured some alerts that were notifying us about the problems in the cluster. And this cluster had problems. It was not highly available. Despite we did experiments for disaster recovery and we knew what to do, in which case it was still required a lot of manual actions to be made. And it was hard to manage because it was created using the plain scripts and it was not easily recreatable. So we have added high availability to the cluster by joining two master nodes to it and created our own automatization scripts. And it became possible to describe the cluster using one file and feed this file into the script that was creating the cluster from the scratch. It was some kind of germs of the infrastructure as a code approach. And I wanted to know that creating highly available cluster at the time was really challenging because official Kubernetes documentation was not describing how to do that in great details. So we had to dig deep into the Kubernetes world to create it. But luckily we found out that there are frameworks for Bash and they are even have an exception handling mechanism, which is amazing. And we took some of the approaches from there for our automatization. This cluster also had problems. It was still hard to manage and upgrade the Kubernetes version. It was really a pain. It was hard to maintain it because it was still a custom logic. And at first we was using our cluster only for the CI/CD, but later we found different use cases for it. And there were more alternatives for managing clusters being developed at that time. So we again searched through the alternatives. They were all pretty good, I'd say, but according to our requirements and in comparison with Rancher, they lost. So we chose a Rancher. It had a really nice UI from which the cluster can be easily created and imported if you have existing one. And it also has a very convenient dashboard, much like the Kubernetes dashboard for managing the cluster and resources. And it was helping us a lot. Under the hood, Rancher uses RKE, Rancher Kubernetes engine, a Kubernetes distribution, which can be used also as a standalone piece of software. And using RKE, the cluster can also be described in a one YAML file. And by running one command, it can be recreated, which is pretty cool and easy. So we used this approach, used RKE, and created our new cluster with it. We also deployed a Rancher and imported our RKE cluster there. And in the most happiest days, our cluster had 14 nodes, 3 masters, and I'd say a lot of resources. Maybe it was not that large because official Kubernetes documentation mentions that it supports for around 5,000 of the nodes, but we still think that our cluster was pretty big. And still, this solution was not very cool. We also still had to provision something manually. and there were issues with the RKE itself. It was not very resilient, so we had to code our own wrapper around it in order to mitigate some problems. And we also wanted to manage different clusters with our solution. And since we created our own wrapper, we had to maintain it, which is not very cool. And since we were already familiar with the Rancher products, we saw that there is an alternative that was being released recently. It was called RKE2. It is probably the best of the both worlds from the RKE1 and K3s. And K3s is a lightweight Kubernetes distribution for running clusters in a limited or air-gapped environment. And creating a cluster with RKE is very simple. We need to just run a few commands on one of the nodes, and RKE will pull all the runtime dependencies by itself. And then we can add as many nodes as we want, as workers or server nodes, by also running a few commands and just feeding the configuration of server to it. And currently we are using this approach for creating our on-premise clusters. It's using Puppet, a configuration management tool that is provisioning cluster nodes, configuring RKE2 there. And we are deploying all the Kubernetes resources using the Terraform and TerraGrant. The resources are like priority maps, namespaces, role-based access control stuff, and so on. And we also created a couple of more clusters using this approach in different locations. And we also tried to use the cloud solutions, the Amazon Elastic Kubernetes Service that we are creating also using TerraGrant with Terraform modules. And we are using it currently for some of our public-facing stuff, and it is working very well. We don't have any issues with it for now, but we are using it for about 1 year, so maybe we are not just as experienced as we wanted to with it. And we also used EKS for some of the experiments, and we also have a plan to use it as a backup if something will be wrong with the EKS cluster, and also a mixed approach with RKE2 and AWS instances. I would like to mention some of the tools that we found useful and can give a positive feedback about. It's a private Docker registry called Harbor that has a lot of features like access control, garbage collection out of the box, and ability to set it as a Docker mirror, and so on. The Canico, a tool from the Google that allows to build the containers, to build the Docker images inside the Kubernetes. All that needs to be done is feed the Docker file to it. And we also built almost all of our images using it. And the Open Policy Agent Gatekeeper that provides a way to enforce policies and restrictions for your manifests to make them consistent across all of the Kubernetes clusters. It's also a very cool tool. We are using it for making sure that all of our workloads are following our rules. For example, we are enforcing that our namespaces have the same pattern, or that our workloads are having the resource reservation set. Okay. And now I will tell you about some problems that we have encountered with our on-premise cluster. And from the first look, they might look silly, but looking back in the past, it was really hard to fix them because we haven't had any good expertise at that time. And the first problem is kind of divided to 3 small parts because they share the same cause. And probably the first issue that we have encountered in our cluster was that we saw that on occasion some of our workloads are just stuck and they are not doing anything, not producing any logs, just waiting for something to happen. And the logs were not showing anything useful for us. We tried really hard, but haven't found anything. The only thing that we saw is that it was happening on the nodes that had really a large uptime. So while we were searching for the proper solution, we applied a hack and we created a service that was rebooting the cluster nodes using the rolling strategy, and strangely enough, it fixed our problem. Also, when we were deleting the nodes, we saw that some of them are staying in the terminated state for like days or weeks or even more. And also we were debugging everything that we couldn't find any useful information, only some logs about problems with Docker. And we also tried to search the help on the GitHub, but no luck. And it was happening only with our the most largest pods in the cluster, the test consumers, from the many containers and volumes and stuff. So again, we applied a hack. Every place that was calling the deletion command, we changed it to use the force version of it. And it luckily fixed the issue for us. One day we received a notification about the full disks on some of our nodes. And we are building a lot of stuff very actively. So there are a lot of Docker images are being produced. And we had a cron job that was cleaning them up, unnecessary images. So we saw that the processes related to the cleanup of the Docker containers were hanged. And again, GitHub no help, Google no help. So again, another hack. And we just added a logic that was handling the hanged processes and killing them before the running cleanup again. So as a solution for this problem, we just upgraded Docker. And we knew that the Docker was the culprit from the beginning, but we already were using the latest supported and suggested version by the Kubernetes. We also tried to use the latest available Docker version, and it was not helping us. And many other people, according to GitHub. And after they released a new version and we upgraded to it, everything started to work normally. And overall, I'd say that from the Kubernetes 1.16 and Docker 18.09, everything started to work great in our cluster, and we haven't had any issues, any major issues with it. And a little side note, as you might know, the Kubernetes recently deprecated the Docker. It was not compatible with the Kubernetes, so they had to create and maintain a special lawyer called Docker shim that was making the Docker compliant with the Kubernetes ecosystem. And now they removed it completely. So now we have to choose from the different container runtimes, like Containerd or Creo, which we are using. But you can also use Docker if you want. There are like solution for this also. The second problem that we have faced was that our core Kubernetes components was dying, and restarting in a very rare case. And we saw in the logs that they are being evicted by the more prioritized stuff. And who might have thought that system components are not defended from the eviction and they are not critical by default. So as a fix, we utilize the priority class feature and special annotation for marking the workload as critical, and we set it for all of our critical components. Also, we were seeing that on occasion our kubectl commands are not being executed very fast. We saw that etcd cluster was telling us that it wasn't able to process all the requests. It was screaming. And we tried to tune the configurations of our etcd cluster, but it didn't help. So we thought that the problem is in the hardware, the disks, and etcd on the official site provides suggestions and recommendations for the disks, and our disks were in the range with those values, but it still seemed like the problem was the disks. So we decided to test them, and the etcd nodes provides a very convenient way to check the metrics of each node in the form of like histogram with percentiles and stuff. And also there are a benchmarking tool from the etcd where you can check your disks for the performance. And also we used some of the external applications to test our disks, and yeah, they were not very good, so we just replaced them with the better ones. Also, we saw that some of our cron jobs are not being started at the correct time, and the issue was that the controller manager that is responsible for starting the jobs was using its local time from the container to schedule the jobs. And the fix was easy, just to propagate the time from the node to the container. And from the recent versions of Kubernetes, there is a possibility to set the time zone for the cron job directly with the manifest. Also, very interesting problem for us. We saw that that all of our requests to the kubectl are not working. So it seemed that kube API server was not healthy, and the high availability for it was configured using the combination of keep alive that was providing a virtual IP and HA proxy that was load balancing the requests from this VIP to the available API server. And we saw that we don't have virtual IP anymore. It was just gone. We also saw that the version of Keep Alive was upgraded for some reason. And after some debugging, we saw who upgraded it. It was the unattended upgrades, a feature of Ubuntu or Debian that is automatically applying the security and other patches when they are available to keep your system up to date. And this was kind of unexpected for us. So to fix this, we just restarted the Keep Alive D, as it seemed that it was just stuck in the upgrade mode for some reason, and moved the configuration of virtual IP to the HA proxy. Someday, we saw that one of our nodes is not ready. It was not doing anything, kinda. It had a really high load average, and it was completely overloaded. It was not even possible to connect to it with the SSH. And after connecting to it, there were many processes from our build pipeline, which didn't have the limits set for the resources, and it just destroyed the node. It stole all the resources from the system processes. Kubernetes provides a way to configure the reservations for some of the system stuff more atomically, and we used it, configured the reservations for the system-related processes and separately for the Kubernetes-related processes, thus making the amount of allocatable resources to the client less. So we also saw that after doing this, our cluster became more stable. And so we added the missing limits for our job. Probably the most common problem and the easiest to fix. We saw that our certificates just expired. We knew that they are going to be expired, and we thought that there are always plenty of time to address this issue, but how it always is, they just expired. And kubeadmin provides a way to rotate them via the one command, so we did it, fixed everything and saved the day. And also we configured alerts for expired certificates and configured rotation. And from the recent versions of Kubernetes, there is a feature for enabling auto-rotation by setting a specific flag for the kubelet. And in RKE, it's enabled out of the box. So we thought that we are packed enough to not face this issue once again, but suddenly Rancher just stopped to work. And it uses the K3s cluster, Kubernetes cluster under the hood. So you might assume what happened. The certificates inside it just expired. And the fix was simple, just to remove the old ones and restart the Rancher container to regenerate them. And this also fixed the day. When we upgraded our Kubernetes version, we saw that our consumers that were running the tests started to fail and produce false positive results. And the Kubernetes was the only thing that was upgraded. CI-related code was not touched. So we started to review the changelog. And we also saw that the container from our test consumers that was running the headless browser was being restarted due to the failure of liveness probe. And Kubernetes provides different types of probes. Readiness, that is telling when the container is ready to receive the traffic. Liveness, that is telling when to restart the container and start up, telling when the container is fully initialized. So we had liveness probe configured. And then we find a tiny note in the changelog that the timeout parameter for the probes was not even working till the version 1.20 of Kubernetes. And they just fixed it. So it started to work as it should. And by default, it is 1 second. And because of this, our probe was failing. So we just added this parameter with a proper value. Not really a problem, but improvement that we agreed to make, we saw that our consumers have a very long start time because they had to pull a lot of Docker images. And Docker images are produced during the build step, and they are then pulled by the consumers. And there was a gap between the push of the image to the repository and pull from it. So we decided to create a tool that was warming up the images on the cluster nodes as soon as they're being pushed to the Docker registry. Oh, something is weird with this. Okay. Don't know how this happened. So, and the architecture of this was not very hard. The client, the Bamboo in our case, was sending the warm-up requests to the core application, saying which images to warm up. And it was just distributing the requests to the daemons that were running on each node, that were just doing Docker pull. And to propagate this pull to the local Docker, we just mounted the Docker socket there. And also, we wanted to create this application because we didn't want to use the PHP because there were a lot of parallelism in this application, and we decided to use Rust programming language for making this application fast and stable. And the Rust is the most loved language for the last few years, according to Stack Overflow questionnaire. It has a lot of advantages, like godlike compiler, high speed, and so on. And you might know that currently it's very hard to find the new software engineers. Everybody wants to work with something exciting and interesting. So we thought that Rust would help us with this. And we also had a few enthusiasts and a little bit of experience with it, more than with other languages like Go. So we decided to give it a try. Despite this is not a very easy language, it has steep learning curve and not a lot of documentation, but every language has problems. And going back to our CI/CD pipelines, so we improved them, made them stable again, and we wanted to not lose the state, and decided to create some kind of performance monitoring for it. The Bamboo was providing some information about our pipelines, but it was not enough. But luckily, we had all the build output in the artifacts. And we also agreed to create a tool on Rust that was parsing those artifacts. And it was a really hard task because there were a lot of steps in our pipelines. They were being called in parallel, and there were a lot of nesting inside. But we made it, combined this data with the data that was fetched from the Bamboo EVA API, and created something like a tree-like structure that was describing our build with all the steps and stages. And we decided to persist this data in the APM, Application Performance Monitoring System. And it is basically a tool that provides a way to collect the information in form of transactions and visualize it. And the transaction can be anything like API call or processing of some message with the consumer or build in our case. And we were already using this tool for tracking and profiling some of our APIs and consumers. So we persisted this data and received some kind of timeline for our build that we used for making some improvements and adjustments in it. And it might not look very convenient because those lines are not kind of collapsible in our version of APM, but in the latest one it is, and we are in the process of migrating to it. And the good thing is that everything that is going to the APM is also available in the Elasticsearch. So we used this opportunity and created some kind of dashboards in Kibana that was showing useful for us information. And we also configured notifications that were signalizing us when there are build degradation detected. Also during the work with the Kubernetes, there was a tool created also in Rust that was monitoring the metrics of the servers of our cluster. It helped us a lot during the debugging of the issues, and it is even open sourced, so you can take a look at it or maybe contribute if you want. So in the end, I would like to say that Kubernetes, as you might already know, is very complex and big system. And if you don't have a dedicated person who will be working 24/7 on your Kubernetes infrastructure, achieving stability will be a very hard task. So it might be better to use the cloud solutions, so you won't have nightmares. And possibly because of that, we started to use the cloud solutions like Amazon EKS, and they are fixing all the issues for us. We don't have to deal with this stuff about expired certificates. What's wrong with this? Works on my local. So, and we still are on our way to adopting the Kubernetes. Not everything is migrated there. And we are looking for different tools and solutions to make our infrastructure better. And try Rust. You see, it wants you to try it. Maybe not from the first day or the first week, but after a couple of months, you will love it. And we are hiring. If you are interested in the positions listed on the screen or in the link, you can chat with me or with somebody from INTEXSYS after the DevClub, or just send us CV. And we are mainly interested in senior or middle positions, but we can discuss everything. And also, if you want to try Rust, you're welcome. So thank you. I hope you enjoyed this presentation. And sorry if it was a little bit vague in some places. Maybe next time we will make something better. Thank you.
Just because we have limited time, so let's do it this way. Now, maximum 3 questions, and if there are more, then you come straight to Aleksandr in a break and ask them. But so, if you have questions, let's do it now.
Thank you for your story. It was really, really interesting. What steps would you skip now, knowing what was previously?
I'd say that we would stick with the cloud solution from the beginning for all of our stuff. And I guess from some point, using the cloud for the CI/CD workloads is not very efficient. So I'd say we'd have a small cluster for our CI/CD pipelines, and all other we put to the cloud from the beginning. And also, our team, as I already said, was not a DevOps team, so it would be better for DevOps to start everything and set up our infrastructure, because now we are migrating the responsibilities to them, and they are fixing all of our problems.
How many people were engaged in all this setup and then all improvements?
So for the part, like the first 3 versions of cluster, I guess, like 3 people, maybe like this. Only our team. And later, a lot of DevOps were involved. So
on average, 3 to 5 people and 4 years from.
yeah, maybe something like this. Yeah. But we were not actually maintaining it. It was at some point just working. We were not doing anything and wasn't doing any improvements. It was like a not very great road for us.
Okay, one last question, is there? Anyone brave? Yes.
Are you still using Bamboo?
Yes.
How is it going?
It's going. It is how it is, I'd say. So they will be deprecating the on-premise Bamboo, and we had to choose what to use next instead of Bamboo. And we thought that we will use the Bitbucket Cloud, which basically is a Bitbucket plus Bamboo. You can write the pipelines there. Or maybe we will use something different like Argo CD and stuff. Or maybe we also tried the Spinnaker CD tool from the Netflix, but we don't know is it good or bad. So for now we are sticking with the Bamboo, maybe next 2 years, and then we will decide.
Okay, thank you.